All right, so in this video, we're going to look at how to factor with fractional exponents. So we're going to start with a slightly simpler case, and then we will go and look at a slightly more complicated case. So in this first example, we have rational exponents that have a common denominator already. If you are working with an example that does not already have a common denominator in the exponent, that is the first thing that you should do. Rewrite your exponents so that they do in fact have a common denominator so that we can work with them. And then, of course, in this case, we also have coefficients out front, which we're going to also try to factor. So the first thing that we recognize here is that we do have a 2 that's in common, so we'll pull that 2 out. Now, we have to leave a 2 behind, of course, on the second term because we can't pull all of the 4 out, only part of it. Now, the second thing that we should understand is that when we're factoring, we can factor out the smallest degree exponent. So in this case, what we're going to try to do is factor out the x to the 3/2. So 2x to the 3/2. And then what's going to end up inside of our parentheses is essentially we're going to divide each of our terms by x to the 3/2. So x to the 3/2 divided by x to the 3/2, and then x to the 7/2 divided by x to 3/2. Now, what that's going to do for us then is we have our x to the 3/2 out front. But now inside of our parentheses, we're going to have x to the 3/2 divided by x to the 3/2 is 1. So this makes sense. We've factored out the whole x expression. And so when you divide a number by itself, you get 1. If I were to redistribute x to the 3/2 times 1, I would get x to the 3/2. In the second term, I'm going to subtract the exponents. So I can think of this like 7/2 minus 3/2 in the exponent. And 7/2 minus 3/2 is 4/2. 4/2 is a 2. And so now what I've done is, again, I pulled out my fractional exponent, and now I have an expression that, at least in this case, simplified to where I have no more rational exponents. So if I needed to proceed now with additional arithmetic, such as setting these things equal to 0 or something like that, I now could continue with that algebra. Now for our second example, we have expressions that have a little bit more complexity to them. We have x plus 1 raised to the crazy exponent and x plus 1 raised to another crazy exponent. And our fractions are our coefficients are fractions. So that makes things a little bit more complicated. Now, in this case, what we can do is we do have a common coefficient, which is the 5. We can factor that out. And the other thing that we can do is, again, we can take out the expression that has the smaller exponent. Now, what does that leave behind? Well, that's going to leave behind a 1/3. And again, presumably, we're dividing out the factor that we factored out. So that's going to leave us with a 1, right? So the 1/3 comes from this coefficient. I took out the 5, but the 3 in the denominator was left behind. And then this expression divided by itself, as we saw in the previous example, this term divided by itself, it just leaves a 1. Now, for the second one, we're going to have the 1/8 left over. And now we're going to have our exponent is going to be the old exponent minus the one that we factored out. And so that's going to simplify to 5x plus 1 to the 3 over 5. And then in our expression here, we're going to have 1/3 plus 1/8 and x plus 1 to the 8 minus 3 is 5 to the 1. Now, if we wanted to, of course, we could try to find a common denominator and then factor out the common denominator to make this even a little bit easier. So let's consider our common denominator, since these are relatively prime, would be 24. So we would have 5x plus 1 to the 3 over 5. And then we would have multiply 1/3 by 8 over 8. We would get 8 over 24. And we would get 1/8 would multiply by 3 over 3. We would get 3 over 24. And since we now have a common denominator, we can actually pull the common denominator out along with the 5 that we pulled out previously. So this would become 5 over 24, x plus 1 to the 3 over 5. And then what would be left behind would be our 8 plus 3 times x plus 1, which we could then further simplify. Oops, that's a 3, not a 2. And then we would have 8 plus 3x plus 3. And finally, 5 over 24, x plus 1 to the 3 over 5, and 3x plus 11. And again, the whole idea behind doing this now is that we can compare expressions that maybe initially looked a little bit different, but maybe algebraically similar. We can now set this equal to 0 if we were trying to find a root or an intercept or something in order to graph the expression. But now we have everything simplified.